Salutations, my little triglets. Welcome to a new chapter. Chapter 11. Chapter 11 is titled Conic Sections, not comic, even though math can be really fun and funny. Conic sections comes from the word cones. So if you take a cone, whoa, let's go back, get rid of that, start over. Here's our cone. And you slice it in many different directions. If I slice it straight across, it's going to make a circle. If I slice it slanted, it will make an oblong circle, which is called an ellipse, and we'll talk about that some other time. So the cone can be sliced many different ways, and it makes conic sections. So the first conic section we are going to talk about is the most popular circle. The formula goes something like this: x minus h squared y minus k squared equals r squared. Now this h and k is the center of the circle, where r is the radius. So for example, if I have x plus 5 squared, y minus 3 squared equals 36. The center, now notice up here these are both minus, so to get a plus I needed to have a negative 5. Here it's just plain old 3 because the minus is already there, so it's opposite of what is in the parentheses. So that's my center. Radius, this is r squared, so the radius would be 6. So drawing this, I would go negative 5, 1, 2, 3, 4, 5, and up 3. And then I would go 6 in every direction, so I'd be out here, up here, out here, and down here. So that would be the circle. That's not a bad circle. A little off center, but I'm kind of proud of that. All right, what if I had something simple like this? X squared plus y squared equals 16. Well, there is no parentheses on either one of them, or there are no parentheses, so the center is 0, 0, and the radius is 4. So I just go 4 in every direction and draw the circle. Okay, it looks like an egg. Now I got to bragging, so now my circles aren't looking as good. All right, let's look at a different type of problem. Let's say I want to find the equation of a circle. It has a center of 3, negative 1, and it passes through the point negative 2, 2. Now, what you need for a circle is center and radius. Well, we have the center. We need to figure out the radius. So let's draw a quick sketch. Drawing a sketch always helps. Go over 3 and down 1. There's your center. Negative 2, 2 is here. So that's, the circle passes through that point. So you have to kind of visualize that circle. So if I were to find the radius of that circle, from there to there, I'd have to find the distance. So a couple ways you can do it. You can just draw a triangle and figure out your Pythagorean theorem, figure out those values, or you can just do the distance formula, which is kind of the same thing anyway. So we have x minus x squared, y minus y squared, all under the radical. So let's put these in. I've got x and y here and here, so I have 3 minus negative 2 squared and negative 1 minus 2 squared. So that's 5 squared plus negative 3 squared. 9 plus 5 is 34, or 9 plus 25. So square root of 34 equals r. Okay, so now we have our two pieces. So the equation is x minus 3 squared y plus 1 squared equals, now this squared is just plain 34. Okay. All right, so the equation of the circle, let's go back a page here. One more. Right here, this equation is standard form. Okay, that's the best form there is to be able to get to draw the picture quickly for a circle, but it doesn't always come in that form. The other form is called general form. General form comes from foiling out standard form. Okay, so if I foiled all standard form out, you would end up with x squared plus y squared plus 4x plus 6y. Oops, let me back up. I'm doing the problem already. I don't want to do that. So x squared plus y squared plus dx plus ey plus f equals 0. Okay, so it's got an x squared and x, a y squared, a y, and then a regular constant number. So let's do a problem with general. I want to find the center and radius of this equation. X squared plus y squared plus 4x plus 6y minus 3. Well, center and radius you can't see when you just look at this, but if this were in standard form, we can pick it right out, h and k and then r. So we are going to work backwards. We're going to unfoil it to get it back to standard form. Now unfoiling is just a common name. What we're going to actually do is called completing the square. Okay, so we're going to learn to complete the square. We're going to add stuff to this equation in order to force it to go back to standard form. All right, first step, you take x squared plus 4x, and we're going to leave a blank because this is a quadratic that we're going to eventually turn into something like that. All right, do the same with the y's. Y squared plus 6y plus blank. Eventually it will turn into something like this. Now this 3 is just kind of in the way right now. We're going to move it over. Okay, so we'll put it over there. All right, this is where we got to think a little bit. When you have like x plus 4 times x plus 4, you get x squared, then you get 4x and 4x, which would be 8x. And then you do 4 times 4 to get 16. So we added the 2 to get the 8, and we multiplied the 2 to get the 16. So if I had to add to get 4x, that means it must have been a 2. And then if you take the 2 times 2, just like we did 4 times 4, that's a 4, so that's what we're going to add in. We're adding in the 4 to complete that square. Now I can't just add a 4 to the left side of an equation. In algebra, you have to add things the same on both sides. So that's what I'm going to do. All right, so now let's see if we can do this other one. So I get y plus, now I had to add to get 6, so that must have been a 3. And then I have to square the 3 to get this to be 9. So to go from here, you cut it in half. To go from here to here, you square it. So I just added 9 to the left side, so I need to add 9 to the right side. All right, so far I have x plus 2 squared plus y plus 3 squared. All this added up gives me 16. Now the center and radius are very easy to find. So center is -2, -3. And the radius, this is r squared, so radius is 4. All right, so you might want to watch that again because completing the square is a little complicated, but if you follow this right down here where you cut it in half and then you square it to get those missing pieces, then it usually is not so bad. All right, one little word of warning. Sometimes you might get at the end r equals 0 or maybe r equals -4. If r comes out to be 0, that means the radius is 0. Think of that. If you have a circle with no radius, don't you just have a dot? So they call this a point circle. Okay, and if you get negative, can you have a negative radius? You know, is that possible? Maybe in another dimension or something, or if the circle turns inside out or something. But for our cases, we're going to say no solution if you get a negative radius. There is no circle that works for that. All right, so that is it for notes. Actually, we have more notes to come, but we'll do those in class. So be ready to do that tomorrow. And always remember to love Trig because it will love you back. Ta-ta for now.